Kia ora. Limits. What happens to the function f of x is equal to x squared minus 9, all divided by x minus 3, when x equals 3? Substitute that in now and see what you get. Hopefully by doing so, you find that the function's undefined because you've got 0 divided by 0. But what happens for values below 3, tending towards 3? Substitute in 2.9, 2.99, 2.999 into the function now and see what you get. Hopefully you should find that the function values are 5.9, 5.99 and 5.999 respectively. So what's happening there is that they're tending towards a value of 6 from below. If we now look from above and substitute in some values like 3.1, 3.01, 3.001, you should find that you get a function value of 6.1, 6.01, 6.001. So what's happening is that even though at x equals 3 the function is undefined, if values of x very close to 3 are substituted into the function, the result is very close to 6. So this is our first introduction to limits. So the limit of a function. We can formalise this by saying the limit of a function f of x as x tends towards a is the value the function f of x gets very close to as x gets very close to a. The limit must be the same regardless of whether x approaches a from above or below. So often I use my fingers, and if they're pointing towards the same function value, then I say there is a limit. If not, then there's no limit. This is an example where there is no limit. So a function may be approaching different values from either sides, and in this case we've got a parabola up to the value of x equals 1, and then we've got a straight line for x is greater than 1. If I get my fingers and look, are they pointing, tending towards the same function value or y value? No, they are not. So that means we say the limit as x tends towards 1 does not exist, or there is no limit. The limit is not always the same as the value of the function. So in this example, you can see here, we've got a parabola y equals x squared up until x equals 1. And then for x is greater than 1, we've got a straight line y equals x. But that solid green dot at x equals 1 is in fact the function value. So the function has a value of 2, but the value of the limit as x tends towards 1, using your fingers again, is that y equals 1. So therefore, this is what we call the limit as x tends towards 1 is 1. Sometimes the function increases without limit. So for this hyperbola, if you have a look, as x tends towards 1, the two branches are converging away from each other as opposed to diverging, coming together. So we would say the limit as x tends towards 1. Are our fingers coming together? No, they're not. So it does not exist. So what I want you to do now is to go to page 244, exercise 14.01, and look at every question in that short exercise. Good luck.